Please support me through PayPal to devinwyndham@gmail.com. I also tutor both in person and online. I am based out of Fairfax, Virginia. So if you are interested in tutoring, you can also reach me at this email. Okay, right now I want to do a calculus minimization problem. This is a soup can problem. A soup can of 1.5 liters is to be constructed. The material for the top costs 4 cents per square centimeter, while the material for the bottom costs 6 cents per square centimeter. The material for the sides costs 2 cents per square centimeter. Which dimensions will minimize the costs for producing the can? Assume that the soup can is a right circular cylinder. All right, pause the video, try it on your own. Okay, let's do it together. Notice I made some mistakes. It's true you can erase with a pencil and you can't erase with a pen, but I still prefer writing with a pen rather than writing with a pencil because I find pencils to be scratchy and annoying and they're constantly getting dull. All right, big C is frequently used to represent cost. I guess a capital letter because it's the sum of a lot of little costs or something. But anyway, C equals pi r squared times 0.04 because the bottom costs 4 cents per square centimeter plus 0.06 because the top costs 6 cents per square centimeter plus 2 pi RH times 0.02 because the sides cost 2 cents per square centimeter. A liter is 1,000 cubic centimeters. So we have that 1,500 is equal to pi r squared h. Notice I separate my mathematical sentences with commas because separating them with the period could get mistaken for a multiplication symbol or a decimal point. Notice I just write like I'm writing a novel all the way across the line instead of going down. That's to save paper. All right, we're studying single variable calculus. We haven't learned multivariable calculus yet. So since we're minimizing cost, notice cost is a function of two variables here, as it's written here, r and h. We need to get rid of one of those variables. Let's get rid of the h. So to do that, we'll solve this for h and plug in. Frequently in school, when we solve, we're used to putting the variable that we solved for on the left, but what's the point? Seriously. So I just leave the h where it is because it's easier on my brain, right? So just leave it where it is. All right, so we'll plug in. Again, to save paper, when you're doing advanced math, your equations can be broken up by more than one line. It's just like when you're reading a novel, a sentence may go on, maybe broken in the middle of a line. So the cost is equal to pi r squared times 0.1 plus 0.04. The 0.02 gets married to the 2 to give the 0.04 times pi r and then h, which is 1,500 over pi r squared. That all is equal to pi r squared times 0.1 plus 60. 0.04 times 50. 0.04 times 1,500 is 60 over r, which is 0.1 pi r squared plus 60 times r to the negative 1. dCdr is equal to 0.2 pi r minus 60 r to the negative 2, which is 0.2 pi r. All right, let me talk about what I'm doing here. So we're trying to minimize cost, so we're looking at its derivative. So we want to analyze the sign of the derivative. It's sort of hard to analyze the sign here, so let's get rid of this negative exponents. Okay, so 0.2 pi r minus 60 over r squared. Okay, so we want to analyze the sign, meaning is this positive or negative of this expression. When we're doing this, I'm going to call this the sum of rational expressions because at least one is a rational expression. This because we've got, a fraction. It's rational. When I'm doing this, I want to combine it all into one fraction. What do I mean by when I'm doing this? When I'm analyzing the sign of a sum of rational expressions, this could be considered a rational expression, I guess, because it could be over 1. I like to combine them. So we'll combine them. We'll find we'll just add them. Find a least common denominator. So 0.2 pi r cubed minus 60 over r squared. We're going to analyze the sign of this guy. Notice the bottom is always positive, so it suffices to analyze the sign of the numerator. Obviously, the numerator is 0 when r is equal to 60 over 0.2 pi, quantity to the 1/3. And obviously, this numerator is negative if r is inferior to this, and positive if r is greater than this. So obviously, when r is equal to this quantity, the cost is at a minimum. So this is our radius. To find h, we'll just plug in the radius to this expression. So h is equal to 1500 divided by pi times 60 over 0.2 pi to the 2/3, which is approximately equal to 22.85. I want to see if this is reasonable. I know this is in centimeters, so I convert it to inches because I'm so I can think in both, just to make sure it's reasonable. So if a soup can is 22.85 centimeters tall, that's 9 inches tall. That's a pretty tall soup can. But I guess, all right, the radius, if we type this in the calculator, is about 4.57 centimeters, which is about 1.80 inches. Okay, that's I guess a reasonable radius. So there's our answer. Notice that this soup can is tall and skinny. It would probably tip over easily. So even though it's the cheapest one, the manufacturers or the soup company, whatever, might not choose to use cans of this dimension because they might topple over easily.